Here's a circa 41, 42 Truetone sold by Western Auto, AM radio, and 78 RPM phonograph combination. This unit was actually built by Admiral and rebranded Truetone. Even the record changer was made by Admiral. And I even have our schematic diagram printed off of the internet. Picked this up at the flea market a month or so ago, so instead of it sitting here for the next 10 years, let's open it up and see if we can get it operational again. And here's the chassis. It looks like just a standard 5-tube chassis. There's our field coil speaker mounted to the front of the cabinet, as well as our loop antenna on the rear. I think I'll leave all that in place because I think I can work on this chassis in the position that it's in. Here's the underside of the chassis. I can see the power cord was replaced at some point and then whacked off at another point. I picked up this radio and a little Stromberg Carlson AM/FM set from the same vendor. That radio also had a cut power cord. He said he bought these at a church rummage sale that he bought out. And he said he thinks the church clipped the cords off of these, probably for liability purposes. They didn't want somebody buying these and plugging them up and fire and smoke shooting everywhere, and then the person wanting to sue the church for it. I mean, you know how sue-happy people are these days. Okay, here's our power input to the radio, and this is a hot chassis set, meaning one side of the AC power line is connected directly to the chassis, and our power switch is in the neutral side of the power line. Well, to make this set as safe as possible, number one, we need to use a polarized line cord with the narrow blade of the power plug being the hot side, and we want to move this power switch from the neutral side up here to the hot side of the line. And the reason for that is because if we leave the power switch in the neutral side of the line, we still pose a threat with a hot chassis, because when the set's turned off, AC comes around through the hot side, through the series string of tube filaments, back to the chassis. And whenever I was taking electronics, they taught us that maximum voltage exists across an open circuit. So in order to prevent this problem, we simply move the switch to the hot side of the line, and we'll also replace this C10, this across the line capacitor, with a AC safety capacitor. And yeah, you can probably hear my advisory committee in the background going crazy every now and then. Now this switch here is for the phono motor, which it can stay where it is. It's not a problem. Now, as a collector and someone who works on this stuff, I'm familiar with the safety precautions to take when dealing with hot chassis sets, but if this thing was to ever wind up in the hands of someone else who didn't know, you know, the thing needs to be made as safe as possible for such persons. Now, one word of warning: all this goes out the window if the outlet that it's plugged into is miswired. So that's why you need to either purchase one of those little inexpensive outlet checkers or use your AC voltmeter to confirm that your outlet is wired correctly. But with this modification, and assuming your outlet is wired correctly, the threat is greatly minimized. Here's our new power cord. The narrow blade is the hot side, the wide blade is the neutral side, and we want to keep the neutral side going to chassis. Okay, we have everything disconnected from the power switch, and before we proceed, let's make sure the switch is good, and that's a simple matter. We just have our ohm meter set on the continuity buzzer scale connected across the switch. We'll just turn the switch on and see if we get anything. And that's perfect. So the switch is good. And here we have a nice fresh new power cord mounting grommet here to protect the power cord from the chassis, possible sharp edge of the chassis. Okay, here's our rewired line cord in place. neutral going directly to the chassis, hot side going to the switch. We have our blue wire coming from the other side of the switch around here to the rectifier tube socket. We also have our AC line bypass capacitor from the switch to chassis. And we also replaced there was a 0.05 microfarad capacitor from the cathode of the rectifier tube to ground right here on the schematic. Now if this cap were to short, then our B plus voltage would be shorted directly to ground, and then that would be goodbye rectifier tube. And while we were working on this, our 50L6 output tube fell apart, and it looks like someone had already boogered with this before, but fortunately 50L6s shouldn't be too hard to find around here. Of course, we'll hang on to this old octal tube base. We might need an octal plug for something one day. Okay, we found a 50L6 and a organ donor radio, and we have the set plugged into our variable AC power supply. We'll bring it up gradually from 0 volts to standard 120 volt line voltage and see what happens. Well, nothing has exploded yet, but obviously we have no stations. Well, correction, we do have a station. It helps when you place the switch in the radio position instead of phono. However, our output is very weak and distorted. I have the volume turned all the way up. Now let's find out what's causing that. Probably a bad coupling capacitor. First, let's check our voltages on the audio output tube, our plate voltage, screen grid voltage, control grid voltage, and cathode voltage. I'm especially interested in this control grid voltage here. It's coupled via C7. Let me start over. The plate of the 12SQ7 driver tube is coupled to the control grid of the output tube via C7, and a lot of times C7 will become leaky, allowing DC voltage from the plate of the driver tube to make its way to the control grid of the output tube. And these output tubes really don't like to see DC voltage on the control grid, so let's see what's there. Checking our control grid voltage on the output tube, we have we're fluctuating between about 1.5 and 1.7 volts, so that indicates this coupling capacitor is leaky.
Gospel Radio, 1390 AM and 93.1 FM, General Revenue Service targeting.
The plate voltage on the driver tube is about 30 volts. That seems a little low. And checking our plate and screen grid voltages of the output tube. About 33 volts on the plate. About 31 on the screen. Those should be well over 100 volts. And about 2.8 volts on the cathode. So let's see why the B plus voltage is so low. And as I expected, our cathode voltage coming off of the rectifier tube, which is our source of B plus voltage, is low, about 30 whatever volts. I'm not detecting any shorts on the B plus line with our ohm meter. So right now, let's go ahead and just replace that leaky coupling capacitor and see what happens. Okay, while I have the capacitor loose, I'm checking the grid resistor on the 50L6. It's supposed to be 500K, and it's reading almost double that. So we'll just go ahead and replace that with a modern day equivalent, which will be 470K. Okay, I'll replace the coupling capacitor. The tone capacitor that connects between the plate and cathode of the output tube, the grid resistor that measured double, and the cathode resistor that was supposed to be 150 ohm, but it was measuring like 175 ohms. I know that's not that bad out of tolerance, but I just decided to go ahead and replace it while I was in there. Well, we no longer have a positive voltage on the grid of the output tube now, but our B plus voltage hasn't gone up any. If anything, it dropped down to about 22 volts. Well, I substituted another 35Z5 rectifier and it jumped up to 45 volts, which is still not nearly enough. So I think whatever's hogging it down probably has damaged the original rectifier tube. My next items on the suspect list are these filter capacitors, so let's take those loose and test them. Okay, so far it seems that this electrolytic capacitor is open. Yeah. So let's go ahead and replace the and the other electrolytic is reading about 15 microfarad with a relatively high power factor measurement, also known as ESR. Let's check for leakage. Well, yeah, at a higher voltage this capacitor is showing leaky. So let's replace these electrolytics and see what happens. Okay, here are our new filter capacitors installed. Let's fire it up and see if the voltage comes up to what it's supposed to be. Okay, this is still not right. We're only up to about 30 volts. Let's try the new rectifier tube and see what that does. Well, no, first let's make an ohm meter measurement of the B plus line and see if there's any shorts to ground. I'm on the 200k ohm scale and there's no shorts to ground here, so what could be causing this issue? Okay, a new rectifier tube took care of the problem. You might recall that I said I'd already swapped out the tube earlier and the voltage only came up to like 40 volts. So apparently the old filter capacitor damaged the original rectifier tube, but now our voltage is up to what it's supposed to be. Now we'll tackle the other problems that this set has. Okay, we still have a lack of volume and sensitivity, so let's figure out what's going on here. Okay, our audio circuit is working, as you can hear, so that pretty much confirms that the trouble is in the front end of this set. Okay, we've replaced all of the capacitors and it's still not working right. Imagine that. That just goes to show that capacitor replacement is not the be-all, end-all. Okay, that's about it for this video. In the next video, we'll take our signal tracer and determine exactly which stage is causing the problem. It could be the oscillator and mixer stage, it could be the IF stage, or it could be the detector stage. We know the audio stage is working by the buzz we got earlier. So stay tuned, part 2 will be up shortly. And these old capacitors are leaking like crazy. Here's capacitor number 1, number 2, number 3, number 4, and number 5. So yeah, even though these capacitors did not cure our main trouble, I just wanted to illustrate that they were indeed leaky and need to be replaced anyway. Okay, stay tuned for part 2 coming up in the next probably 24 hours or so. Well, I had a pretty good day at the flea market. Picked up this 48 Philco battery set in a Bakelite cabinet, just a 4-tube battery set that runs off of a 1.5 volt and 90 volt battery pack. So you'll get to see that restoration video one day. And we picked up this RCA Victor model V100 radio phono combination from 1939. Now the outside of the case is in pretty good shape except for this little veneer chip here. But the inside, however, has some issues. This motor board is not in the best shape. And someone has hacked in a newer tone arm at some point in time. You can see that's where the original tone arm was. It was a big Bakelite tone arm. So they drilled a new hole and mounted this newer tone arm. I'll need to try to find an original tone arm and try to patch this up. But for $10, not really complaining too bad. And I also hauled off some 4 black plastic crap modern day TVs that still work, but it's getting to the point you can't sell those anymore. Nobody wants them for any amount of money, which is a shame. And I don't really need to get in a rant about that, but I just got tired of them being here, not moving, and taking up space, so I gave them to my buddy that runs one of the flea markets and told him if he can make a few dollars off of them to have at it. But we don't want to dive into the RCA radiophono until we get our Truetone radiophono wrapped up. And as you recall, we fixed some power supply issues in the last video, but we still have very weak reception. And off camera we replaced this 250 ohm resistor that feeds plate voltage to the driver tube. Here's the original resistor. It's supposed to be 250K. It's reading 457K. I replaced it with a modern day 270K ohm resistor, which is close enough. Well, we might not even have to break out the signal tracer. I did some more spot checking and found some problems in the front end. This is a 10 meg ohm resistor, or it's supposed to be. However, on the meter, I'm on the 20 meg range and it reads wide open. Here's another resistor. Looks like either a 15K or a 25K. I can't tell if that first color is brown or faded red. And the schematic is not too clear, but whatever, it's reading 45K, which means that one has gone way up in value. Probably not enough to kill the set, but needs to be replaced anyway. And who says Mica capacitors don't leak? Although it's not leaking as wildly as some of the paper capacitors that we've tested, it's still leaking. So if we replace these parts, the set may very well come to life. It certainly can't hurt anything. Here's our new 10 meg ohm resistor, so you can see that my meter is not fouled up. Well, I'll replace the 2 resistors, leaving the capacitor in place for now. And our situation may have improved a tad bit, but it's certainly nowhere near where it should be. Okay, I'm now going to replace that original Mica capacitor, which is a 50 picofarad. It just so happened I had one 47 picofarad left in stock, and as you can see, it's not leaking at all. Okay, there's the new capacitor in place. Let's give it a try and see if it helped it or hurt it. Somehow I have a sneaky suspicion it's not going to make much of a difference. Well, that didn't make one iota of difference. So before we break out the signal tracer, I think we're going to break out the signal generator and check the alignment of this set. It's quite possible somebody's got a hold of this with a golden screwdriver. And I feel like an idiot if that's what's wrong with it. We have our generator hooked up and set to the IF frequency of 455 kilocycles. It may be a little off, but it's not that much off. So I guess while we're here, we'll go ahead and peek out the IF alignment. Well, this second IF may be a little bit out of whack, because whenever I turn the trimmer, it gets louder. That's about it right there. Okay, these trimmers were off a little bit, but I don't think enough to cause the lack of performance that we were experiencing. Well, that helped a little bit, but not nearly enough.
TrueCar.com is changing car buying.
Getting more stations now, but not very strong.
Free guarantee.
There's the 10,000 watt station. It should be blasting in. There's the hot religious station. There's the black gospel station now very faintly. We're making progress, but we still have a long ways to go. And by the way, I have substituted tubes already, and that didn't help the situation. Okay, well, it may be time for our duh moment here. Notice on the tuning condenser, most tuning condensers have two trimmers on them, variable trimmers. This trimmer here for the oscillator, this trimmer here for the antenna. Well, notice there's no screw adjustment on here, so that makes me wonder if somebody removed that screw for some reason. You know, most people think radios work better with the screw tightened. Well, maybe whoever did this thought it would work better if you removed the screw. And according to the alignment instructions, it does say to adjust this trimmer for maximum gain. Well, I can't adjust it if there's no screw there. So I guess I need to dig around here in my junk and find an old tuning capacitor that I can borrow a screw from and see if we can adjust this thing. Okay, thank goodness for junk. We found a screw that would fit here. Now let's fire it up and see if we can adjust this thing into better performance. Okay, looking at this closer, we have some more missing parts. You notice on this oscillator trimmer, we have our top portion of the trimmer, the top contact, if you will. And then I believe there's a mica insulator between the top contact and the bottom contact. Well, all we have here is our bottom contact. The insulator and the top contact is missing. So I'm either going to have to find a tuning capacitor exactly like this one to rob those parts off of, or I'm going to have to mount an external trimmer on here. Of course, option number 2 will be most likely what happens.
No, an audit's premature.
Okay, I couldn't find the appropriate parts to fix the tuning condenser, so I dug around and found a trimmer off of another old junk chassis, and I'm starting to rethink the fact that this ever had a trimmer on the tuning capacitor. The trimmer we're using is a variable capacitor, actually, that spans the range of about 0 to 40 picofarad. Well, connecting this trimmer doesn't help the situation. Its best effect is whenever the trimmer is set to 0. The higher in capacity you adjust it for, the worse the reception is. And I tried another 12SA7 tube to no avail. So the only other thing I know to do now is check out this antenna very closely. I'm going to feel real stupid if that's what the problem is. Okay, here's our slightly repaired loop antenna assembly. Really couldn't find anything wrong with it except for the deteriorating wires here that I repaired with heat shrink tubing. And I replaced the isolation capacitor for the external antenna lead. And I added a bit longer lead there for the external antenna. Although in a strong signal area such as this, you shouldn't need an external antenna, but apparently this radio has a problem receiving. And here is our antenna trimmer here, so that explains why there was not one on the tuning capacitor. Now, won't I feel real stupid if I hook all this up and give the antenna trimmer a tweak and it come in loud and clear after doing all of this. Okay, this did absolutely no good, and adjusting the antenna trimmer on the back of the set here does absolutely no good, so I don't feel quite as stupid. Okay, I believe I found something that's more concrete than anything I've found so far, and I'm a little bit in disbelief here. The secondary winding of the first IF transformer is wide open. Now that really surprises me because generally when these windings open, you get no reception at all. And on this one, as you could hear, I was getting some reception. It just wasn't that good. And even with the signal generator, I was able to shoot a 455 kilocycle signal through the mixer stage all the way through the rest of the set, and it seemed to be fairly stout. But the meter doesn't lie. This winding is open. And here's the winding right here. One side of the winding goes to the control grid of the IF amplifier. The other side of the winding goes down to the AVC line. Now the next order of business is to remove this IF transformer and see if I can possibly repair the defective winding. Even if I have to replace the transformer, I don't think it's anything that non-standard. I'll probably have something in my junk somewhere. Well, here are the innards of the defective IF transformer, and unfortunately I don't think there's anything I can do with it. The leads are not broken anywhere visibly, so evidently the break is down inside of the coil winding, and I tried resoldering the leads on the terminals to no avail. So our only option is to dig around in my junk and try to find another IF transformer. Well, I dug around in my junk and I found this old Sears Silvertone chassis. It looks like it has something that will work on it. So let's pull this IF transformer off, make sure the windings are good, and if they are, we'll stick it in this set here and hope for the best. Okay, here we are. Now let's see if this one's any good, and even if it is, we're going to have to take it apart and replace those wires. Okay, there's the primary winding, 32 ohms, that looks good. And the secondary winding, so yeah, that looks just fine. And it even physically lines up with the chassis, so that's good. Okay, I guess we'll end part 2 here, and in part 3, we'll rewire this transformer and install it and see if it'll work.